5% skill, 15% concentrated power of will, 5% pleasure, 50% pain, 100% reason to remember. Thanks for joining me again on As I Learn, and currently I am posting things about C++ as I get better and learn new things, even basic things, because I've done a little bit of C++ in my career, but not enough to really amount to anything, and I want to get better at it. So I'm going to be talking about integer types this time, and we're just going to go over a couple of things that you may not know about C++ and integers. So let's get started. So the first thing that we're going to do is we are going to get rid of this boilerplate code. And you can use whatever IDE you want. I use CLion by JetBrains, but just about any C++ IDE, Eclipse or whatever, Xcode if you're on the Mac, Visual Studio if you're on Windows, work just fine. Just create a new project, and really we're just going to go over creating an integer. So if we create an integer, let's call it value equals, let's just say like 45321 or something, and then we will see out that value, and then let's just say down here, let's change it to value something really long, and then let's see out again. And let's fix my error here. So let's run this. Okay. Actually, that's not going to let me show you what I wanted to show you, so let me save this and run it again. So if you can see in the console here, we get our value printed to the screen. Let's just change this to something really long. Oops, hit a little keyboard shortcut on accident there. And save it and run it again. So if you notice, when the value has gotten too long, it just prints out something really strange and weird, because there is a limit to how large an integer can be in certain languages. So how do we know what those values are? Well, I'll show you that in just a second, but let's just say we want an integer that's this value. All you have to do is change it. You can create it. Let's just create another value here, and let's go back to our first value, and then let's go long int L value equals, and then let's make it something like this. So as you can imagine, if we run again, we're going to get the value we expect because we added the integer type long to the end of it here. So let's just add some, include a library here. Most systems should have this. So if you get an error when adding this, you'll just have to do some Google searching, because I'm not real sure why you're not able to include it. It'll have to do with whatever compiler you're using. So if you're using something different than the GCC compiler, I guess is what it's called, I'm going to say include limits like this, and let's also, well, if I could spell include correctly. And then let's also say that we want to use the name space std for the standard library. Oh, we already had that in there. Wasn't paying attention. All right. So how do we know what the limit is of this guy? Adding the limits library set of tools will allow us to take a look at that. So we can say cout int max inline, just like that, and let's run it. So here's our limit to just our regular integer value. If anything above this guy is going to give us a weird integer when we try to set that above this value. So there's also a minimum value that you can have a look at as well. And what you'll notice is it's negative +1 of that number for whatever reason. So I thought that was pretty interesting. So what if you want to have an integer and you want to ensure you want to inspect its size and know how much memory it's taking up. So there's a convenience method that we have access to. It's actually an operator that we can use to see how large of a memory footprint these two values. And the reason you would want to do that is, let's say you're only requiring, maybe your specs require that you really only use a certain amount of memory to store a value, and we've typed it as a long, but long takes up more memory space than just a regular int. So you would want to ensure and inspect how big of a memory footprint that thing is taking up is one reason you might want to use this. So I thought this was another cool little thing that I learned whenever I was just learning some basics in C++, which is you can do cout, let's just say size of int, like this, and then we'll do size of, and let's put int in here. And let's do this again. And I'm going to use a keyboard shortcut to duplicate that, and I'm going to say long. Let's put that in there. And let's run the code again. And in case you're wondering, I'm just using the keyboard shortcut Control-D. Actually runs the compiler again. Your IDE will probably have a debug button of some sort, or if you're doing it from the command line, then obviously you know what you're doing there. So I'm going to run the compiler again, and it says that int takes up 4 bits and long takes up 8 bits. So let's inspect the long value that we set here, and I'm going to copy this and inspect this. So just for fun, let's copy this first value and assign it to our long value as well and see what the results are. So as you can see, even though the numbers are the same, long actually takes up more memory than int. So that's a good case for if you know you're never going to go over a max size of int, or you're not going to go under a min size of int, then it makes good sense to use the int value without the long, If you know that this number might start out small and eventually grow beyond the max value for whatever reason, then you're going to need that memory to store the long value. So that's a good case for, planning ahead. If you are going to be writing some code that has a lot of integer values or whatever, you can make decisions on what the type of that variable is going to be and how much memory it's going to be used by the system to store that value. And one other thing to point out that I did know, but I might as well talk about it since we're talking about integer values. There's another type. You can say unsigned int, and what this does is it only allows you to create positive integer values. You can't have a negative value at all. So if you see out u value, like that, and then let's create another one. Let's do u1 value and try to make it a negative value of some sort and see out that. And run it. So if you notice, you're going to get kind of a weird value if you try to assign a negative value to a unsigned integer versus one that's a positive number as well. So that's something else to be aware of. If for whatever reason you want to restrict, you don't want a value to ever go into the negative for whatever reason, you can always make it require it to be an unsigned integer as well. So anyway, quick little kind of run through of what I've been learning in C++ in regards to integers, and hope you'll join me next time for whatever else I'm learning as I learn it. 10% luck, 20% skill, 15% concentrated